Hi guys, welcome back. This week we're talking about ions, isotopes, and average atomic mass. Last week we talked about the atom and its electrons. Um, so let's go ahead and get started. Today is November 9th. Happy weekend. I know the weekend was great for some of us. So let's get started. So our learning target is I can differentiate ions from atoms. And our do now question is why atoms are considered neutral. Well, we need to remember that atoms contain protons, neutrons, and electrons. The protons and neutrons are in the nucleus, while the electrons are in the orbitals around the nucleus. Now, as you know, the neutrons are neutral charge. They have no charge, meaning they don't determine the amount of force that the atom has or the amount of charge the atom has, right? The protons and electrons do. Now, as of the moment, the protons equal the number of electrons. The number of protons equals the number of electrons. If you're wondering how do we find out how many protons our atom or our element has, it's based on the atomic number. The atomic number tells us how many protons we have. But as of the current moment, our number of protons equals our electrons, meaning our positive equals our negative, causing the overall charge or the overall force to be neutral because they cancel out. However, that's not always going to remain true. So let's see what I mean by that. So over here we have the sodium element or the sodium atom, right? And we see that we have 11 protons based on the atomic number, which is 11, and we also have 11 electrons because our protons equals our electrons. Now, if we're not sure about that, we can also look at our electron configuration of sodium, which is 2, 8, 1, which we add up, it will give us 11. So we have 11 electrons, 11 protons. Now, 11 positives and 11 negatives cancel out, so we have a zero net charge. So that's what I meant. However, that's not always going to be true. If you look at the next image over here, we have a positive ion. What is an ion? We will talk about that in one moment. But we have a positive ion where we have Na plus 1. Now that plus 1 is telling us that we no longer have, if you look at the image, we have a lost an electron. So now instead of us having 11 electrons like we had in the neutral atom, we now have 10 electrons. And the overall charge of the sodium atom would be plus 1 because now our protons no longer equal our electrons because we lost an electron. So what's an ion? Well, we have two types. We have cation and anion. But an ion is basically an atom with a charge. And an atom with a charge because it's either gained or lost an electron. So an atom with a charge due to the fact that it lost or gained an electron. Now when it loses an electron is a cation, and we notice that because it has a plus sign. If it gains an electron, it's an anion, and we notice that because it has a negative sign. So when we lose electrons, remember our protons are supposed to be equal to our electrons. But when we lose electrons, we become more positive because we have more protons than we have of electrons. Now, if we gain electrons, we become more negative because now we have more negatives than we have of positives. So a couple of examples of an anion would be magnesium 2 minus. Now magnesium, let me get this pen out real quick. Magnesium's electron configuration is 2, 8, 2. But this 2 minus is saying that we gained 2 electrons. So it's now actually 2, 8, 4. And it's become more positive. It gained 2 more electrons. If we look at our cation, we have fluorine 3 plus. Fluorine's electron configuration is 2, 7. But this 3 plus means that it lost 3 electrons. So its actual electron configuration for the ion is going to be 2, 5. Now let's remember this is for the ion. This is not for the atom, this is for the ion. As long as we see this 2 minus, even though electron configuration changes, as long as we see this 2 minus next to magnesium, or we see this 3 plus next to fluorine, we know that these electron configurations are for those elements. They've just lost or gained an electron. So let's go ahead and practice this. Let's practice this out. It's the best way we know how. So we have carbon, and then we have carbon 4 minus, right? Now remember, I always like to flip it. So if minus in the real word means to take away, if I flip it, it actually means to gain, right? So minus, and I always like to put my little notes here, gain, and then plus in the real world means to add on, but we actually, in this case, we're losing. Chemistry is all about opposites and honesty. So carbon, we have to determine if it's neutral or an atom. Well, if we look over here, there's no sign. So that means it's mostly, if there's no sign, we always assume that's a 0. So that means it's neutral. The charge, well, the charge is going to equal to the amount, the charge is going to be 0. Because at this moment, our protons equals our electrons. The atomic number will be 6. So the number of protons would be 6. Number of neutrons would be 12, which is the mass, minus 6. So the number of neutrons would also be 6. And the number of electrons would also be 6. So this is how we get a neutral charge. So over here, we have to determine if it's a neutral. We have C4 minus. And we have to determine if it is a neutral atom or an ion. Well, we have the 4 minus. So that means the moment we see this, we already know that this is an ion. If I wanted to be a little bit more specific, I can say this is an anion, right? Its charge is going to be -4, because that's what this number indicates. And then the atomic number is still 6. The protons are still 6. The neutrons are 12 minus 6, because 12 is the mass, and 6 is the atomic number, or it's the atomic number, so which gives us 6. But now instead of us having 6 electrons, we added 4 electrons to it. So now in actuality, we have 10 electrons for our carbon atom. All right, let's go ahead and let's try another one. Right? So, I know it says activity 1. We're just going to do it right here. Right? So, we have lithium. The name would be just Li, which would be lithium. Right? It's a neutral atom. So if they're saying it's a neutral, that means my number of protons would be equal to my number of electrons, which lithium happens to be the third element. So it's going to be 3. Now, lithium has a mass of, give me 1 second to find out. Don't know this off the top of my head like I like to do. Lithium has a mass of 6.9, so we can say 7. So 7 minus 3, which would give us 4. And then the number of electrons equals the number of protons, right? So P equals electrons, right? But let's look at this. We have Li plus. When we usually don't see a number next to it, we always assume it's a 1. If we don't see nothing there at all, we assume it's a 0. So because this is Li plus, this is actually going to be lithium ion. There's a certain way that they name ions that we'll talk about. So it is is it an anion or a cation? Well, an anion is the minus, so a cation would be the positive, right? So it's a cation. Now the number of protons does not change, so it's still 3. And the mass number does not change either, so it's 7, which is the mass, minus 3, which is the atomic number, equals 4. But now our protons no longer equal our electrons, right? So we have 3 originally from the atom, but this 3 and this plus 1 is telling us we actually lost 1. So it's actually going to be 3 minus 1, which means you actually have 2 electrons for this lithium ion. All right? So go ahead, practice the rest of this out, and come to the live session to see how you're doing. The last thing that I wanted to mention is if you're an ion from the right, sorry, if you're an ion from the left side of the periodic table, so left side PT ions, their names end in an ion, meaning we get lithium ion, we get sodium ion, we get um magnesium ion. It's magnesium plus ion. But so the name ends in an ion. However, if you're on the right side of PT, the periodic table, your name ends in an "ide," right? So you're not going to see fluorine ion. You're actually going to see fluoride. You're not going to see bromine ion. You're going to see bromide. So the name end of the name ends in "ide." We'll talk a little bit more about this when we get to bonding, but that's how you also notice by the name it's an ion because it ends in an "ide" or ends in an ion. That's how there's one way we can notice it's an ion as well. All right, see you during the live session, and if you have any questions, please feel free to reach out to me or Mr. Schwartz. We are most definitely here to help you. Have a great day, guys.